Did you know our moon might be a chip off the old Earth block? That's right, our moon, that celestial body that's been lighting up our night skies for as long as humans have been around, might actually be a piece of the Earth. The leading theory about the moon's origin is the giant impact hypothesis. Picture this. 4.5 billion years ago, our planet was a young, fiery ball of molten rock. Suddenly, a Mars-sized body, affectionately known as Theia, zooms into the picture, hurtling towards Earth at an astronomical speed. The inevitable collision was more than just a bang. It was an event of cosmic proportions, a cataclysm that would shape the destiny of our planet. The force of the impact was so immense it sent a shower of debris into the Earth's orbit. Imagine chunks of rock, hot and glowing, spinning around the Earth in a chaotic dance. Over time, this debris started to coalesce, drawn together by their mutual gravitational pull. Bit by bit, these fragments of Earth and Theia started to form a body, a new entity born from the chaos of the cosmic collision. And so in this violent and turbulent process, our moon was born. A child of the Earth and Theia, a testament to the raw, untamed power of the universe. Isn't that something? From a cataclysmic collision to a serene celestial body that's become a constant in our lives. The moon, our moon, is a piece of our own home planet. But the story doesn't end there. The giant impact hypothesis is still just that, a hypothesis. There's much we don't know about the moon, its composition, its history. Scientists are still working hard to unravel the mysteries of our lunar companion, to piece together the cosmic puzzle that is our moon. So, if this theory holds, our moon is a piece of our own home planet, a silent witness to our planet's turbulent past, a constant companion in our journey through the cosmos. The moon, ever enigmatic and ever captivating, forever a piece of our earthly home. Ever wondered why the moon has dark spots? These mysterious dark plains, known as lunar maria, are a fascinating feature of the moon's surface. The term maria, Latin for seas, was coined by early astronomers who, when gazing upon the moon, mistook these large, dark expanses for bodies of water. But as our understanding of the moon evolved, so did our knowledge of these dark spots. Instead of water, we found that these plains are the result of ancient volcanic activity. Imagine, if you will, a time when the moon was not the quiet and serene celestial body we know today, but a tumultuous world of molten rock and fiery eruptions. These volcanic eruptions spewed basaltic lava across the moon's surface. As the lava cooled and solidified, it formed broad, flat plains. This is why the lunar maria appeared darker than the surrounding highlands. The basaltic rock, rich in iron and magnesium, reflects less sunlight, giving the maria their distinctive dark appearance. The discovery of the lunar maria not only revolutionized our understanding of the moon's surface, but also provided valuable clues about its geologic past. For example, the size and distribution of the lunar maria suggests that the moon's interior was once far more active than it is today. Furthermore, by studying the maria, we've been able to learn about the moon's past magnetic field, a crucial piece of information for understanding how the moon evolved over time. The lunar maria also serve as a reminder that the moon, often seen as a constant and unchanging fixture in our night sky, has a dynamic and violent history. They are a testament to the moon's fiery past, a time when it was alive with volcanic activity. So the next time you look up at the moon, remember that those dark spots you see are not just simple features on a distant celestial body. They are a window into the fiery past of our quiet celestial neighbor. These dark spots are a window into the fiery past of our quiet celestial neighbor. Did you know we only see one side of the moon from Earth? Yes, that's right. This fascinating phenomenon is due to something called tidal locking. This is when the gravitational pull of a larger celestial body, like our Earth, causes a smaller one, such as the moon, to rotate on its axis at the same rate it orbits. Hence, we always see the same face. In other words, the moon's day is as long as its year. Quite a mind-bending thought, isn't it? So what about the far side, the one we never see? Until the space age, it remained a complete mystery. It was only in 1959 when the Soviet Luna 3 spacecraft provided the first ever glimpse of the moon's far side. The images sent back were grainy, but they revealed a world starkly different from the familiar face we see from Earth. The far side lacks the large dark spots, known as maria, that make up the man in the moon on the side we see. Instead, it's heavily cratered and has a terrain full of mountains. Scientists theorize this difference is due to the moon's crust being thicker on the far side, making it harder for molten material from the interior to reach the surface and form maria. The moon's far side also hosts one of the largest known impact craters in our solar system, the South Pole Aitken Basin. This gigantic depression measures about 1/4 of the moon's diameter and is around 8 times deeper than the Grand Canyon. It's a window into the deep lunar mantle and offers valuable clues about the moon's early history. Moreover, the moon's far side is also an excellent location for radio astronomy. It's shielded from the Earth's radio chatter, providing a quiet place to listen to the cosmos's faint signals. The far side of the moon, a mystery for centuries, is now another testament to human curiosity and exploration. From tidal locking to the first spacecraft images, each discovery peels back a layer of the moon's enigmatic allure, leaving us in awe of the secrets our cosmic companion holds. Enjoying the journey so far? If you're captivated by these lunar mysteries and can't wait to explore more of the cosmos with us, then we have a small request. We'd love for you to become part of our community. How can you do this? It's simple. Just hit that subscribe button below. By subscribing, you will not only be supporting our channel, but also ensuring that you don't miss out on any of our future videos. We regularly delve into the mysteries of the universe, exploring everything from black holes to alien life. But that's not all. Make sure you also click on the bell icon. This will turn on notifications, so you'll be the first to know whenever we release a new video. Now, let's continue our cosmic journey. Join us in the next scene as we delve into another fascinating aspect of our moon, its shrinking problem. Can you imagine our moon is actually shrinking? Yes, you heard that right. Our very own moon, the celestial body that has been a constant companion to Earth for billions of years, is getting smaller. But don't worry, it's not going to disappear anytime soon. In a recent discovery, scientists have found that the moon is slowly but surely shrinking and quaking. This isn't the result of some cosmic diet or an alien construction project. No, this is due to a process that's been ongoing for billions of years. The moon, like Earth, is a geologically active body. It was formed from molten rock, and over time, this rock began to cool and solidify. As it cooled, it also contracted. This contraction is what causes the moon to shrink. But the process doesn't stop there. The cooling and contracting of the moon's interior also leads to moonquakes. Yes, that's earthquakes on the moon. These aren't your garden variety tremors either. These quakes can be quite powerful, registering up to 5 on the Richter scale. Now, you might be wondering how we know all this. Well, scientists have been studying the moon for decades, using everything from telescopes to lunar rovers. But the real breakthrough came with the Apollo missions, which allowed astronauts to place seismometers on the lunar surface. These devices have been recording moonquakes ever since, giving us invaluable data about the moon's interior. This discovery challenges our previous beliefs about the moon. We used to think of it as a dead, static world, but now we know that it's a dynamic and evolving body, with a geological life of its own. So next time you look up at the night sky and see the moon, remember that it's not just a silent, unchanging orb. It's a world that's cooling, contracting, and quaking. Our moon, it seems, is more dynamic and alive than we ever thought. What if we told you there's water on the moon? Yes, you heard that right. Despite its barren and dusty appearance, the moon holds a secret beneath its surface: water. This isn't a recent revelation, but a mystery that has intrigued scientists for decades. Our understanding of the moon's water took a significant leap forward in the late 20th century, when orbiting spacecraft detected signs of water ice in the permanently shadowed craters near the moon's poles. These are areas that have never seen the light of the sun, remaining bitterly cold, perfect for preserving water ice over billions of years. This discovery sparked a wave of excitement among scientists and space enthusiasts alike. Why, you ask? Well, the presence of water on the moon could revolutionize our approach to future lunar exploration and even colonization. Imagine a scenario where astronauts could use this water, not only for drinking but also for producing breathable oxygen or hydrogen fuel for their spacecraft. This would dramatically reduce the amount of resources needed to be launched from Earth, making space travel more efficient and sustainable. However, the moon's water isn't readily accessible. It's trapped in the form of ice, hidden deep within the moon's harsh, rugged terrain. Extracting this water would be a challenging endeavor, requiring advanced technology and innovative approaches. Yet, the potential rewards far outweigh the difficulties. The discovery of water on the moon presents us with an exciting opportunity. It could be the key that unlocks a new era in human space exploration, paving the way for sustainable lunar bases and even perhaps a stepping stone to the farther reaches of our solar system. So, the next time you gaze up at the moon, remember that beneath its rocky exterior lies a resource that might just propel us into a new chapter of space exploration. Water on the moon, once a dream, is now a reality that could unlock our future in space. Ever heard of moon dust? It's not as harmless as it sounds. Picture this. You're an astronaut stepping onto the lunar surface for the first time. You're in awe of the desolate beauty around you. But there's a hidden danger you might not be aware of. Moon dust. This isn't the soft silken powder you might be imagining. Lunar dust is a nuisance, a peril, and a riddle all rolled into one. So what makes this dust so troublesome? For starters, it's incredibly abrasive. Thanks to the lack of atmosphere and weather on the moon, these tiny particles aren't worn down and smoothed out like they would be on Earth. Instead, they're jagged and sharp, capable of damaging spacesuits and machinery. But it doesn't stop there. Lunar dust is also notoriously clingy. It readily adheres to everything it comes into contact with, thanks to the moon's electrostatic environment. This stickiness can cause all sorts of problems, from obscuring vision in helmets to clogging up important machinery. Now you might be wondering, how does this dust come into existence? Well, the moon's surface is constantly bombarded by micrometeorites. These tiny space rocks hit the surface with such force that they pulverize the lunar rock into a fine dust. Over billions of years, this process has created a layer of dust that covers the moon's surface. But it's not all doom and gloom. This pesky dust also provides us with invaluable insight into the moon's history. By studying it, we can learn about the moon's geological past and its exposure to cosmic rays and solar winds. So, while it might be a headache for astronauts and engineers, this dust is a treasure trove for scientists. It's a peculiar paradox. What causes trouble for some provides answers for others. Moon dust, a tiny but formidable challenge in our journey to conquer the moon. This minuscule menace may be small in size, but it's a giant hurdle in our quest for lunar exploration. But remember, every challenge we overcome brings us one step closer to unraveling the moon's many mysteries. Our moon, a familiar sight, yet filled with mysteries. As we journeyed through the lunar enigmas, we started by delving into the moon's contentious origins. The giant impact hypothesis, the leading theory, suggests that a Mars-sized body collided with Earth about 4.5 billion years ago, leading to the formation of our moon. Yet inconsistencies in this theory keep the debate alive, and the moon's birth remains an enigma. Next, we ventured into the lunar maria, those dark plains that paint a face on the moon's surface. Formed by volcanic activity, these regions are surprisingly rich in titanium, a pattern we don't see on Earth. This peculiar concentration of titanium is another lunar riddle that beckons our curiosity. Then we turned our gaze to the moon's far side, the side forever hidden from Earth's view. Unlike the near side, the far side is heavily cratered with a thicker crust. The reason behind this stark contrast between the two faces of the moon is yet another lunar puzzle waiting to be solved. We also discussed the moon's perplexing shrinking problem. The moon is getting smaller, causing its surface to wrinkle like a grape turning into a raisin. The root cause of this lunar contraction is still a topic of discussion among scientists. We touched on the moon's water mystery as well. Recent discoveries of water in sunlit lunar areas challenge the long-standing belief that the moon's surface is completely dry. The source and the extent of this lunar water is another enduring mystery. Finally, we talked about the moon's elusive dust. This lunar dust, or regolith, is electrostatically charged and sticks to everything, making it a challenge for lunar missions. The unique properties of this dust and its formation process remain a mystery. As we continue to explore and learn, the moon remains a testament to the wonders and mysteries of our universe. No matter how much we learn, the moon continues to captivate us with its enduring mysteries, reminding us that there is always more to discover in the vast expanse of space.